Today we're going to take a look at multiplying polynomials and a little bit of some special products, but mainly just looking at multiplying polynomials and how we do that. So first example, we have a monomial times a binomial. So we're going to distribute. So before we jump into this process, I don't want to go too quick, but before we jump into this process, we got to do a little bit of a reminder here. When I'm multiplying something like x squared times x third, let's say, when I'm multiplying by the same base, what you want to do is you want to add the exponent. So it's going to be x to the 2 plus 3, which is x to the 5th. Just doing a little bit of a reminder. So now that's all we're pretty much going to be doing. So 2x times negative 3x is 2 times negative 3, which is negative 6. We're multiplying the coefficients together. And then you're doing x to the first times x to the first, which is x to the second. X to the first. I'm not going to write this out every single time, but just showing you x to the first times x to the first is x to the 1 plus 1, which is x to the second. Don't confuse this with adding and subtracting polynomials where we just look at like terms and we keep the variable with the exponent the same. Where we're multiplying, we got to actually do our multiplication rules. 2x times 5x squared is going to be 10x to the third because it's 1 plus 2. So multiplying a monomial times a binomial, we're just distributing, done. Number 2, negative 5x times 9x squared minus 2x minus 10, so I'm going to distribute. Negative 5x times 9x squared is negative 45x to the third. Negative 5 times 9 is negative 45. X to the first times x squared is x to the third. Negative 5x times negative 2x is positive 10x squared. It's a bad 0. Wow. X to the first times x to the first is x to the second. And then we have positive, negative 5 times negative 10 is positive 50. And then I don't have anything to multiply the x by here, so it's just going to be x to the first. So just leave that x there. And then we're done. And always just double check. Make sure that there's no like terms that snuck in there, but in this case, no. In this case, no. So we're done with those two. So those were monomials times binomials. So number 3, we have a binomial times a binomial. It's going to be a little bit different. Not like drastically different in scope of it, but just the process here is a little bit different because we have a binomial times a binomial. So what you can do, I'm going to do it the way I like to do it, and then I'll show you what some textbooks say. I have like 2 methods of showing this. I like to do it like this. I like to do distributive property twice. So I like to think of it as x times x and x times 5. So I'm distributing the x to this, and then I'm also distributing negative 3 times x and negative 3 times 5. So what I'm doing is I'm just thinking of it as x times x plus 5, and then I'm doing negative 3 times x plus 5. So I'm just taking this first term, this term here, and distributing to everything in here like that. Let me clean this up a little bit. So again, I did x times x times 5, negative 3 times x, negative 3 times 5. So I'll have x times x is x squared, x times 5 is 5x, negative 3 times x is negative 3x, negative 3 times 5 is negative 15. Negative 3 times 5 is negative 15. Now we have like terms in the middle. Pay attention to that. 5x minus 3x. Those are like terms. So I have x squared. 5 minus 3 is 2. So 2x minus 15. Yeah. I'll use number 4. I know I said I'll show you 2 methods. I'll use number 4 to introduce the other method, which is called FOIL. I really don't like FOIL. I really don't like using this acronym for it, but some people like remember like, oh yeah, FOIL, like it's just easy to remember. It's almost like PEMDAS, you know, you just remember FOIL. I don't necessarily like it because it only applies to very specific scenarios where you're multiplying a binomial times a binomial. Like what happens if I add on like a plus 5 here? Then you can't FOIL this term of FOIL, and that's where people get a little confused of like, wait, how do I do this? So the FOIL method is first you multiply the first terms, outer, inner, and then last. Kind of makes like this weird figure, but that's what FOIL is. Again, I really am not the biggest fan of it, but I just wanted to throw it out there just in case anyone watching this video saw me do this and like, wait, I think I remember foiling, which you could FOIL, that's completely fine, but it doesn't apply to anything else other than binomial times a binomial. So that's why I like to show this method, because I'm going to use this method here on binomial times trinomials or anything other than binomial times binomial, because that's what you could use derivative property. So I'm going to do 4x. I'm going to use the derivative property here. 4x times negative 2x, 4x times negative 10, 3 times negative 2x, 3 times negative 10. 4x times negative 2x is going to be negative 8x squared. X times x is x squared. 4 times negative 2 is negative 8. 4x times negative 10 is negative 40x. 4 times negative 10 is negative 40. And then we just have x because this doesn't have an x or anything. 3 times negative 2x is going to be negative 6x. Same thing as what I said about the 4x times 10. I don't have an x. So this 2x is just going to be 2 times 3 and then leave the x. 3 times negative 10 is going to be negative 30. Then we have some like terms that snuck in there. Negative 40x minus 6x. So I'm going to have negative 8x squared minus 46x minus 30. Negative 40 minus 6 is negative 46x. So I have negative 8x squared minus 46x minus 30. Number 5, we have the same thing. We have a binomial times a binomial, but you'll notice that we have this constant on the outside. What you can do is I would take care of this binomial times a binomial first. I would just do that. And then at the end, you'll just do 3 times whatever that comes out to be. So you'll just treat it as like a normal, what we just did in those last 2 problems. And then after you get that answer, you just treat it like a derivative property. You do 3 times that, whatever amount of terms that we end up with. That's all you would do. So let's go ahead and take care of that. I'm going to do the 2 binomials together. So don't forget about the 3 though. So I'm just going to put 3 and then I'll just put a bracket here. So 2y times y. So I'm doing 2y times y, which is 2y squared. 2y times 3 is going to be 6y. Negative 1 times y is going to be negative 1y because 1 times 1. So negative 1 times 1 is negative 1. And then negative 1 times 3 is negative 3. Don't forget about the 3. And then I have some like terms that came out from here. So 6y minus 1y is 5y. 6 minus 1 is 5. So 2y squared plus 5y minus 3. And then I'm going to distribute the 3. So 3 times 2, 3 times 5, 3 times negative 3. 3 times 2 is 6y squared. 3 times 5 is 15y. 3 times negative 3 is negative 9. So there's that. Three x minus 2y squared. On this one, we could do this 2 different ways. This is called squaring a binomial because it's a binomial just being squared, or you could think of it this way. And there's a method for squaring a binomial. So I just want to show you how you could approach this. So squaring a binomial is, I'll do that second. Because this is another one of those things where I don't necessarily like the squaring the binomial because it's like a formula. It's something you got to memorize. I'm not super into memorization, so I'd rather just look at this like, how would I solve this? That's the approach I want to take. So if I have 3x minus 2y squared, I'm squaring a binomial. Just like if you have x squared, what is x squared? X squared is x times x. So what I'm doing is I'm doing 3x minus 2y times 3x minus 2y. So I could write this out as 3x minus 2y times 3x minus 2y. Then I'm just multiplying. The same thing as what I did before. I have a binomial times a binomial, so 3x times 3x, 3x times negative 2y, negative 2y times 3x, negative 2y times negative 2y. So no formulas need to be memorized, nothing that you got to rely on your memory for. You just got to know how to square a number. So 3x times 3x is 9x squared. 3 times 3 is 9. X times x is x squared. 3x times negative 2y is negative 6xy. Negative 2y times 3x is negative 6xy also, because y times x, those are not like the same variable, so we just do x times y, which is xy. And then we have plus 4, 2 times 2 is 4, y times y is y squared. We do have some like terms that pop up in the middle there. Negative 6xy minus 6xy. So 9x squared minus negative 6 minus 6 is negative 12xy. plus 4y squared. So that's the more just brute force type of way. Just knowing I got to square a number. How do I square a number? I just multiply it to itself. There's also called squaring a binomial. And there's a little bit of a formula for this. So the formula is if I have a plus b squared, that's going to be a squared plus 2ab plus b squared. So you're taking a, you're squaring it, you're taking b, you're squaring it at the end, and in the middle you're doing 2 times a times b. What if it was a minus b squared? Well, the formula for that is a squared minus 2 times ab plus b squared. So you're squaring the first term, you're squaring the last term, putting it at the end, and then in the middle it becomes minus 2 times a times b because it's a minus b. So if I use my example here, this is my a term, this is my b term, this is a minus question, so I'd be looking at a minus b squared. So it would be 3x squared minus 2 times a, which is 3x, times b, which is 2y, plus 2y squared. And I really hope you see why I don't do this. Why I just multiply it out by just taking a binomial times a binomial. Look at this process. If you're taking an exam or doing something like really important, like not even just like a class exam, but just taking some sort of standardized test where it's really important that you do this correctly, like I'm not going to rely on myself to remember these formulas. Like I'm not. I need to just know how to do something. That's why I just go with multiplying binomial times binomial. So let me finish this up. 3x squared is going to be 9x squared, because 3 times 3 is 9, x times x is x squared. Then in the middle we have 2 times 3, which is 6, times 2, which is 12. So minus 12xy, plus 2y squared is 2 times 2, which is 4. Y times y is y squared. You get the exact same thing. Way more work, personally. I just think it's way more work. Do whatever you want. I don't care. But that's squaring a binomial. So we'll get number 7, 2x plus 3 squared. I'm just going to take the route of just multiplying a binomial times a binomial. 2x plus 3 times 2x plus 3. I'm going to do 2x times 2x, 2x times 3. So 2x times 2x is 4x squared. 2x times 3 is 6x. 3 times 2x is 6x. 3 times 3 is 9. So rolling along here. And in the middle, 6x plus 6x is 12x. So 4x squared plus 12x plus 9. All of these examples so far were mainly just binomial times a binomial, which we had a binomial times itself or a binomial times another binomial, but that was the process, just distributive property twice. Now, what if we have a binomial times a trinomial? How do we take care of this? It's the exact same thing. Use that distributive property, but this time we're going to do x times 2x squared, x times negative 4x, x times 3. Same thing with the 3. 3 times 2x squared, 3 times negative 4x, 3 times 3. So I'm multiplying everything together, just like how I did before, multiplying it all out. X times 2x squared, so now we're going to multiply all this out. X times 2x squared is 2x to the third. X to the first times x to the second is 1 plus 2, so 3. So x to the third. X times negative 4x is negative 4x squared. X times 3 is 3x. Now I'm doing the 3. So 3 times 2x squared is 6x squared. 3 times negative 4x is negative 12x. 3 times 3 is 9. So plus 9. Let's check out some like terms. I don't think I have anything with the 2x to the third. No, I don't. So 2x to the third. Negative 4x squared. Do I have anything with that? Yes, I have plus 6x squared. Those are like terms. So negative 4 plus 6 is going to be 6 minus 4, which is 2. So 2x squared. And then I have 3x minus 12x. Those are like terms. 3 minus 12 is going to be negative 9x. And then we have that plus 9 tacked on there. A little bit of a process, not impossible or anything like that, but yeah, there's kind of a lot going on there, a lot of multiplication going on. So it's just more attention to detail, being careful, make sure everything is getting that term, that multiplication term. Okay, a couple more. Number 9, we have 3x minus y to the third. Same thing that we talked about with to the second. It's just multiplied 3 times. So it's 3x minus y times 3x minus y times 3x minus y. You're just multiplying it out 3 times. So 3x minus y times 3x minus y times 3x minus y. So I'm going to go through this a little bit quick since we've been doing binomial times a binomial. We've been doing this, so I'm going to go through this a little bit faster. So 3x times 3x, 3x times negative y times 3x, negative y times negative y. So 3x times 3x is 9x squared. So I'm just going to do this first pair of binomials, and then we'll get that answer and then multiply it by the 3x minus y. So I do 3x times 3x is 9x squared. 3x times negative 1y is going to be negative 3xy. Negative y times 3x is negative 3xy again. And then negative y times negative y is positive y squared. Y times y is y squared. Now combine like terms before you multiply by the 3x minus y again. So let's just combine these like terms, because that just makes the terms, it's going to make it a smaller polynomial, so we don't have as many terms to multiply. So 9x squared negative 3xy minus 3xy is negative 6xy plus y squared. And then this whole term needs to be multiplied by the 3x minus y. So this became 9x squared minus 6xy plus y squared is this 3x minus y times 3x minus y, that first pair of binomials. Now it needs to be multiplied by 3x minus y. So this is now the same as what we just talked about here on number 8. Same exact scenario. So be careful here. I'm going to do 3x times 9x squared, 3x times negative 6xy, 3x times y squared. And then we're going to do the same thing here. Negative y, boom, bam. So everything is going to get this term. And it looks kind of weird because I'm going the other direction. But it's the same exact process. So 3x times 9x squared is going to be 27x to the third. Got to be careful here. Really easy to make a silly mistake. Negative 6xy times 3x is negative 18x squared y. 3x times y squared is going to be 3xy squared. Now I'm going to do the negative y. Negative y times 9x squared is negative 9x squared y. So be careful there because it's just negative 1 times 9, which is negative 9. And I have x squared times y, not the same variable, so just write that as x squared y. In the middle, negative y times negative 6xy, that's going to be positive 6xy squared right here. So I did negative y times negative 6xy. So negative 1 times negative 6 is positive 6. I don't have anything to multiply the x by, so then I do y to the first times y to the first, which is y to the second. And finally, negative y times positive y squared, which is going to be negative y to the third. Oh my goodness, we have a lot of like terms, I think. 27x to the third, I don't have anything. I have the minus y to the third, but those are not like terms. But I don't have any x to the third, so 27x to the third, nothing. Let's see, negative 18x squared y. I have negative 9x squared y. Probably shouldn't use this straight line. Come on, erase. Erase. There it is. Negative 18 minus 9 is also negative 27. X squared y. I hope I didn't make a mistake somewhere. 3xy squared, 6xy squared. That's going to be 9xy squared. And then we tack on that minus y to the third. Good problem. Good problem. Not hard. I do not think this is hard. I think this is easy to make a mistake because there's so many terms, there's so many exponents. Like, it's really easy to make a mistake. But I think just the fundamental process of multiplying the variables, adding those exponents, multiplying the coefficients, I don't think that's the difficulty here. I think it is difficult to manage everything. I think that's where the mistakes are going to happen. But if you're careful, you should be okay. And finally, last one. Big lesson here. Number 10, 3x squared minus x plus 8 times 5x squared minus 6x plus 2. So we have a trinomial times a trinomial. And yes, we can, or no, we cannot simplify anything down. So we do have to just take the long road and multiply all of this out. 3x squared times 5x squared times negative 6x times 2, negative x to all of this. And then we have to also do, let me change colors, 8 to all of this too. So I'm going to go through this pretty quick again. 3x squared times 5x squared is 15x to the fourth. 3x squared times negative 6x is negative 18x to the third. 3x squared times 2 is 6x squared. If I'm going a little bit quick, just rewind it. I just want to get through this multiplication step as quickly as possible. The middle, negative x times everything. So this is going to be negative 5x to the third. Negative x times negative 6x is positive. Positive, where was I? Positive 6x squared. See, that's what happens. You get thrown off for like half a second, and you kind of lose your spot. And then negative x times 2, which is going to be negative 2x. 8 times 5 is 40x to the second. 8 times negative 6x is negative 48, right? 6 times 8 is 48x. And then 8 times 2 is 16. Let's go ahead and combine like terms. I don't have anything to combine with the 15, x to the fourth, so leave that alone. Let's see, do I have anything with the negative 18x to the third? I do. I have negative 5x to the third. So negative 18 minus 5 is negative 23x to the third. 6x squared plus 6x squared plus 40x squared. A couple like terms dropped there. Where was that? So let me just double check. 6x squared, 6x squared. Yeah, okay. So that's 12 plus 40. 6 plus 6 is 12. 12 plus 40 is 52. And then minus 2x minus 48 is going to be minus 50x. And then we have that plus 16 constant. Voice is going. There it is. Again, don't think it's hard. I think it is very easy to make a mistake though, but I don't think the concept, the process is difficult. Just got to be careful, as I very well could have made a mistake here after 9 problems of doing this, talking through all of them. Hope I didn't make a mistake. It looks good to me. I was kind of checking it over as I was talking out loud, but I think it's fine. So yeah, this is a good one.